Welcome to AI in Mathematics training. So this demonstration is the part of first module named as Foundational Understanding of Mathematics in AI. In this demonstration, we are going to discuss three types of artificial intelligence and their applications. These three types are machine learning, deep learning or neural network learning, and the third one is natural language processing. Let's talk about the first type of AI, that is machine learning. Machine learning represents algorithms that enable computers to learn from data and make predictions. Let's understand this concept of machine learning through the use of this very basic example. This example involves two variables x and y, where x represents the study hours and y represents the test scores. Here x is taken as the independent variable and y is taken as the dependent variable. Of course, in the real world, we use a large data, but here we are considering the data set involving only 3 points. Now, using this data set, we have to answer this question: how much marks shall I get if I study 4.5 hours? So, we will try to answer this question by understanding a basic concept of machine learning here. So, machine learning here involves 4 steps. Input, which is the study hours represented by the variable x. Output, that is test scores represented by the variable y. So using this data, we will be training a model. So what is the meaning of training a model on this data? The simple meaning of training a model on the data is to find the relation between the variables y and x. That is, to find a mathematical representation of the relationship between the variables x and y. And the fourth step here is, once we have trained the model on this data, that is, we have the relationship between the variables y and x, we will use that to estimate the value of y for new values of x. So these are the simple 4 steps that are involved in a machine learning model, and using these 4 steps we can answer the question, that is, how much marks shall I get if I study 4.5 hours? So machine learning here is simply finding the relationship between the variables y and x. And there are different methods that we can use to find the relationship between the variables y and x for this data. Let's say by using the method of least squares, we find the relationship between the variables y and x, as in y is equal to, suppose, 31.25 plus 23.125x. So once we train the model on this data, it simply means that we have found the relationship between the variables y and x. So we can use this relationship to find the answer of the question, that if I study 4.5 hours, then what would be my marks? Another thing to understand here is, when we say that a machine learning model is being trained on this data set, it means that we have to find the relation y is equal to a plus bx, a simplest relation between these two variables. So training a model on this data means that we have to find a and b values. So once these two values a and b are found, we say that we have trained the machine learning model on this data, and then we can use this relation to further find the values of the dependent variable for the given independent variable value. So this is the very basic concept of machine learning, which we can use to find the answer of our questions. Now let's talk about the second type of artificial intelligence, that is deep learning. A deep learning is a subset of machine learning involving neural networks with many layers. Again, we are going to use this simple example using two variables x and y, where x is representing the study hours and y is representing the test scores, to understand this concept of deep learning. The question that we have to answer using this data of 3 points is, how much marks shall I get if I study 4.5 hours? So first, let's talk about the structure of the neural network here. So the neural network structure that we are considering here involves 3 layers: input layer, hidden layer, and output layer. Input layer uses one neuron, which is basically just the input, that is the study hours, the variable x. Hidden layer has two neurons, and the actual process of the neural network learning happens in this hidden layer. We'll talk about these two neurons later. So the third layer is the output layer. It uses one neuron, and that is basically the output, that is the test score. So what actually happens in the process of neural network learning? So in the input layer, it takes the study hours, and the hidden layer processes input through neurons with weights, biases, and activation functions. These are the main ingredients of the hidden layer, that is weights, biases, and activation functions. And the third layer is the output layer. It produces the predicted test score. So two are the main layers, that is the input layer, which is the input, that is the study hours, and the last layer is the output layer, which produces the predicted test score. That is the answer that we want, that for 4.5 hours what would be the predicted test score. In between input layer and output layer, the actual process of neural network learning happens, and it utilizes weights, biases, and activation functions. Let's try to understand the mathematics behind neural network learning. To answer this question, how much marks shall I get if I study 4.5 hours using this data? So the neural networking structure that we are considering here involves three layers: input layer using one neuron, hidden layer it uses two neurons, and output layer it uses one neuron. So let's look at the geometrical structure here. Since our input layer involves just one neuron, so we will represent this one neuron by using this small circle. That neuron would be the input, which is the study hour. Now the second layer is the hidden layer, and the hidden layer involves two neurons, which we are representing by using these two circles. Now these two neurons in the hidden layer are connected with the neuron in the input layer by using the weights, which we are representing W1 and W2. We'll talk more about these two weights later. So these two neurons, let's name them Z1 and Z2. Now the next step of this conceptualization is, once you have Z1 and Z2, use an activation function phi on these two values Z1 and Z2. For now, phi of Z1 and phi of Z2, phi is an activation function, will simply be the numbers. Next step is to go to the output layer. The output layer involves one neuron, which we are representing by this circle. So phi of Z1 and phi of Z2 will be connected with this neuron like this by using the weights, let's say W3 and W4. So you get, let's say, Z3. Just like in hidden layer, when you got Z1 and Z2, you applied an activation function. Now in this Z3, you will apply the activation function phi of Z3, which would be nothing but just the output, that is the variable y, or here it is the test score. So this is the conceptualization of neural network learning. Let's put this whole structure into the mathematical form. First, we go from input layer to the hidden layer. Now we start with the input x. So you saw that from the input layer to hidden layer, x was connected with one neuron using the weight W1, and x was connected, x is the input, was connected with the second neuron using the weight W2. So when we say that the process of neural network learning begins, what happens is that this process is about finding the weights and biases. So in this step, from input layer to hidden layer, this relationship is found where x multiplied by the weight W1 plus a bias gives you Z1. You can see here that x is connected with Z1 using this weight W1, and we have also added a bias. So this is for one neuron. Now for the second neuron, you see here that x is connected with Z2 using the weight W2. So in this part of neural network learning, another relationship is found, that is Z2 is x multiplied by the second weight W2 plus another bias. So when we say that neural network learning is being conducted from input to the hidden layer, so basically the weights W1, W2, B1 and B2 are going to be determined. Now these two will be called weights and these two will be called biases. Let's try to understand the raw concept behind these weights and biases. Suppose that we say that the test score of a student is 2 times the study hours plus some non-deterministic term. So this 0.6 could represent the luck of the student, or it is that the topic that appeared in the exam was the one where student had the full command on. So 0.6 could represent a term of some probabilistic nature that influenced the score of the student. Now you can see that here 2 could be taken as the weight and 0.6 could be taken as the bias. So in this part of neural network learning, we determine the weights and the biases. Weights and biases represent some features that could influence the score of a student in an exam. Additionally, we could add another feature that maybe the score of a student is 3.6 times the study hours plus some probabilistic term. So here it would be W2 and this would be another bias which is B2. So when we say that neural network learning is being conducted, so in this part from the input layer to the hidden layer, basically the values of the weights and the biases are being determined. Now let's move to the other part of this neural network learning. After this step of going from input layer to the hidden layer, you can see that we applied an activation function on Z1 and Z2. So the next step is that we had this Z1 and Z2, we will apply an activation function on these two numbers. So we apply activation function, let's say activation function here is phi on Z1 and Z2, which we obtained here. So activation function could be taken as a sigmoid function which is represented by this relation, or sometimes an activation function is taken as ReLU, which is described as 0 if z is less than equal to 0 and it is z if z is positive. So this sigmoid activation function is used where we want to have an output in the form of some probability. So once we apply an activation function on Z1 and Z2 in this hidden layer part, we get two numbers, and then the third part of this neural network learning begins, that these two numbers phi of Z1 and phi of Z2 are connected with one neuron in the output layer by using the weights W3 and W4. So for the third part, where we are going from hidden layer to the input layer. Now phi of Z1 is connected with the neuron in the output layer using the weight W3 plus phi of Z2 is connected with the neuron in the output layer using the weight W4, and an additional bias is to be found, which we are calling B3, and we find this relation. Let's say it's Z3. So in this part of neural network learning, three parameters will be found. Two are weights, W3 and W4, and the third one is the bias. So once we find this relation, or mainly we find the values of these parameters, we again apply an activation function on Z3, which gives us an output, or in our case it's the predicted test score, which we will denote by y cap. So what happens is that when we say that neural network learning is being conducted, so mainly we are trying to find the parameters, weights W1, W2, W3, W4, and the biases B1, B2, and B3. That is, we go from input layer to the hidden layer to the output layer. Means we provide our system an input. In between the input and the output, some process happens which involves activation function, weights, and biases, and then finally you get an output. So once we get the predicted test score, we compute the mean squared error. That is the difference between the original test score and the predicted test score and its square. If this mean square error is minimum, we say that our estimation of the predicted test score using the deep learning or neural network learning is correct. But if it is not, then we use back propagation and gradient descent method to update these 7 parameters W1, W2, W3, W4, B1, B2, and B3. We keep on updating these weights and biases until we get the minimum mean squared error, that is the minimum error between the predicted score and the actual test score. So this is the basic mathematics behind the neural network learning that could be used to answer or predict the test score for the given value of the study hours. And the third type of artificial intelligence that we are going to talk about is natural language processing. So natural language processing is a field of AI that enables and eases the communication between a computer and a user. So it enables the machines to understand, interpret, and respond to human language in a way that is both meaningful and useful. Let's see that what steps or processes are involved in natural language processing. Natural language processing involves the following steps. Input, that the user asks a question and it is taken as the input. Then the actual process of natural language processing begins. It involves tokenization, where the sentence or the input is broken into individual words, which are also called tokens. Next step is part of speech tagging. Here, the grammatical parts of each individual word or token is identified. Next step is named entity recognition. Here, specific entities like dates, numbers, locations, and names are identified. These 3 main steps are the part of natural language processing, that is tokenization, part of speech tagging, and named entity recognition. And now after these 3 steps, the response generation process begins. And this response generation process again involves machine learning model or maybe deep learning model or the neural network learning model, such that the answer is retrieved from that machine learning model using the data that is already fed into the computer. And after this step of response generation, the output is sent back to the user. So these are the main steps that are involved in natural language processing. Let's look at an example where all these steps of natural language processing are used. So we have an example of two variables x and y, where x represents the test scores and y represents the study hours. We want to answer this question: how many hours should I study to score 75 on the test? So this question is posed by the user to the computer. That is an input. Now the natural language process begins. The first step is the tokenization. This whole sentence is broken into individual words like how many hours should I study to score 75 on the test. That's the first step of tokenization. Now the second step is part of speech tagging, where each individual word is grammatically identified. That is, what is verb, what is adjective, what is noun, what is the modal verb, what is the preposition, etc. The third step is about named entity recognition. So in this third step, the chatbot identifies the specific entity. So the question was, how many hours should I study to score 75 on the test? In this step of named entity recognition, the chatbot picks the number 75. After these three steps of tokenization, part of speech tagging, and named entity recognition, now the chatbot tries to formulate the response. And this response is formulated using this data involving two variable values, x and y. Again, in the backend, a machine learning model is trained on this data. That is, the relationship between the variables y and x is determined, and that relationship is used to answer this question, that how many hours should I study to score 75 on the test. Once this response is retrieved from this machine learning model, then that response is sent as an output to the user by the chatbot. So based on this data, you should study for approximately 4.5 hours to score 75 on the test. So these are the steps that are involved in the natural language processing. Through this very simple example, we got a very basic understanding of natural language processing.